Thank you so much for being in class today. We already started with logarithm. We started solving questions on it. And at some point, the last class, we went back a bit to some of the things we've done previously. Now we're moving forward. Now what we have is still simplifying logarithmic equations. The previous class we did this, log 1 over 2 in base 3, we've simplified it. Now I said something. In maths, look at what you're told. You're told to simplify. You're told to solve, you solve. That means, in other words, you're going to get the final answer. You're told to express this as a function of this, or you're told to, whatever you're told, convert, you convert. Now this is simplify, giving you a clue that you're not likely to arrive at a definite answer. In some cases too, you might arrive at definite answers. So let's go on with this. We've already done this, so let's go to what we have today. Now this was our assignment. I said you should try your hands on this in the previous video. Now you want to do well to check the previous video, know how we solve this and solve this and solve this, and then we're going here today. So try the previous video. Thank you so much. So let's go ahead without much ado. So what we have here is log in base 5 of 12 plus log in base 5 of 10. Now note that these things are simple maths. Like I said previously, they are simple, but for some people they are not exactly simple. So one of the things psychologically tell yourself is simple. Now, remember what we had in one of the rules in indices and also in logarithm, that if we have a raised to the power of 2 in indices times a raised to the power of 3, what that means essentially is what? A, what? 2 plus 3. Okay, which is a raised to the power of 5. That's one of the rules. Now in logarithm also, in log, when you have log b of a times log b, let's say b raised to the power of whatsoever of a, whichever way. So eventually it's going to be this, because you have both of them being the same thing. The two are of the same base. Let's say b, let's say f, for example. Now is going to be log of b a. This times will change to plus a times f. Okay, this plus this will be times a times f. So that's what we're doing. So something like this in this is another law like this. So the product rule. Now the product rule. Now that's exactly what we're going to apply in this case. For applying the product rule here, this will essentially become, since both have the same base, we're going to be essentially 12 times 10. Very simple. The next is the answer, which is actually log in base 5 of 120. And you get 120. 12 times 10 is 120. This is the answer. Now, by the time you separate, now actually what that means is this. We actually got this from here. We have done actually the reverse. Like, instead log in base 5, sorry, not 10, 5 of 120 actually means what? What is 120? 120 is actually 12 times 10. Is that not true? So by the time you introduce, so it's the same thing as saying log in base 5 of 12 times 10. Now by the time you make this log, separate them and have both of them have their separate logs, this sign of times will change to plus. So it's no longer going to be plus, it's going to be log in base 5 of 12 plus log in base 5 of 10. So this place to this place, or this place to this place. So this was where we started, and this is where we ended. So this is how it is. So once the log is there, we'll get to see this rule where multiplication switches to times. You have addition also, and then multiplication switches to addition when you put your log on, and the other way around when the log is on it. Now the second question before us is this, number 2. 2 log in base 7 of 9 minus log 81 in base 7. Now, looking at this, if you know maths properly, you will know that there's a clue. This and this are just the same thing. Because from the rule, this one means 9 raised to the power of 2. Like what we did yesterday, like I advise look at the previous video. So this is essentially log in base 7 of 9. This one is actually forming an exponent, a power. This one is a power minus log of 7, 81. Question: what is 9 raised to the power of 2? It's saying as 81. So this is log in base 7 of 81. Sorry, 81, not 18. 81 divided by minus log in base 7 of 81. Remember in indices, let's go back when we were there, where you had your rule, the other rule number 2, which is the quotient rule. Thank you. So that is actually, if for example, you have a raised to the power of 3, or let's say raised to the power of 4, divided by a raised to the power of 2. What it means actually is that a is equals to 4 minus 2, eventually. In other words, we is saying as saying a raised to the power of 4 divided by a raised to the power of 2 divided sign. This one will give you a raised to the power of 2. This also will give you a raised to the power of 2. In the same way. The same way with logarithm, you have it. So this minus sign becomes the division sign. Flipping both sides, switch to division and okay, so this flips to this and this flips to addition. So that is what is going to happen here. So essentially, with this rule in logarithm, the product rule would have it as, since both of them have the same base 7, so we use one of them as 81 divided by 81. Right? So 81 times 81 here, 1 here, 1. So what do we have? We have log in base 7 of 1. Then we come to another rule. Another rule states that log of 1 is actually equals to what? 0. As a matter of fact, from here now, this minus this should normally give you 0. So we have to solve it to this place, solve it to this place, come back to the rules. Now that is one beauty of maths. Maths, follow rules, follow principles, you get to where you're going to. And you can always switch maths to this place, and then switch. Oh, this is this. Oh, I remember this is this. So you bring in this. If this is this, I'll bring in this. So it's very beautiful. So we could have ended it here. But we'll sort further to this place, sort further to this place. Remember the rule, this one always equals to 0. So the same thing happens. Thank you for staying tuned. You want some more interesting topics, more interesting questions solved. Follow, subscribe, and like. Share also to your friends. Thank you for staying tuned. I appreciate you. Thank you.